All right, so we have already looked at fundamental quantities. Now we want to consider derived quantities and units. But I need you to know the difference between real units and symbolic units. For instance, velocity does not have a symbolic unit. This guy also, but notice that force has both real unit and symbolic unit. So real units are units you get from the formula, all right? Whereas symbolic unit is the first letter of the first name of the scientist in question. For instance, here we have Isaac Newton who worked on this quantity, on this concept. So we use his name, Newton, as the symbolic unit. Is that okay? Not just force. Let me show you the rest. Again, notice here that momentum does not have symbolic. Work has symbolic unit. Joule. Whereas this is the real unit. You must know the two of them. All right. Then watt is also somebody's name, a scientist's name. All right. Okay. Also notice that pressure has its symbolic unit, Pascal. All right. And this is the real unit. Sometimes you can have different variations. This one and of course this one. All right. Now charge, symbolic unit is coulomb, and this is the real unit from the formula, and then the rest of them. You can pause the video and go through this write-up. All right. Now there are about 8 derived quantities that I'd like you to know in this order, the order in which I'm going to be listing them. Okay, the first one is area, then volume, followed by density. It's rho, okay, density, and then you come to velocity, okay, or speed. You use V as the symbol, and then after velocity you should know acceleration, okay. Then after acceleration you should know force, all right. And then work slash energy, all right, they share the same SI unit. Now force or weight, the unit of force and the unit of weight are the same. Now notice here that this question says list 4 derived quantities that share the same unit in physics. So we've already listed 2 of them. This one is number 1, force and weight, and then work done and energy, they also share the same SI unit. Now the next one should be power, okay, power, and then you know pressure. Then after that you should know momentum slash impulse. Now momentum and impulse also share the same SI unit, change in momentum and impulse. All right, I think we are going to stop here. Once you know these ones, the rest will be very easy for you to grasp. Is that okay? So you start with area. Area is length times breadth or width, all right, and the unit is meters squared, sorry. And then volume is length times breadth or width times height, right? And then the unit is meters cube. Density is mass over volume. So if mass is kg and volume is meters cube, so of course it will be kilogram per meter cube. You can as well write it like this. Velocity and speed share the same SI unit, but of course velocity is vector, whereas speed is scalar. All right, that's the difference. So this is distance, velocity is displacement over time, whereas speed is distance over time, but it's the same unit, meters per second. All right, now acceleration is velocity over time, so that is meters per second, all right, or you can write it like this, meters per second squared. Okay, so force is mass times acceleration. You can as well use mass times g, acceleration, g to gravity. It has to do with vertical distance, whereas this one is horizontal distance, linear acceleration, but it's still the same thing. So the units will be mass is kg, kilogram, meters per second squared. All right, that's for force. But remember that this is the real unit. The symbolic unit is Newton, capital N. Is that okay? And the rest of them, I'd like you to look at the write-up, okay, and figure them out yourself. Also, you should be able to prove that momentum and impulse share the same SI unit. So if momentum is mass times velocity and impulse is force times time. So prove that these two share the same SI unit. Is that okay? All right, so back to the question. Question number 3 says, which of the following units is derived? So this guy is fundamental. This is fundamental. Kelvin, of course, is temperature, fundamental. So the correct option is D. Is that okay? Okay, so pause the video right now and try to figure out the units, real units of this work done. Okay, of course, work done and energy share the same SI unit. All right, then power, do it yourself. Pause the video right now and do that. Now this other one too. Okay, so you pause the video and look at these ones. Pascal, all right, for pressure. Is that okay? All right. So this one is for you. Which of the following is a derived unit? So ampere, that's the unit of current, is fundamental. This one is fundamental. This is fundamental. Ohms is the correct option. Excuse me. From Ohm's law, V is equal to IR. You remember? So R, which is resistance, is V over I. So the unit of volts, voltage is volts, and current is ampere. So this is the unit, okay? Or you can write it like this. All right, so that's ohms. Okay, so what about this one? Which of the following physical quantities is paired with its corresponding SI unit? So A is wrong. Density is kilogram per meter cube. So there is no minus on top, so it's wrong. Power is work done or energy expended over time. So joule per second. So that's correct. Specific latent heat, you remember heat is equal to ml, where L is the specific latent heat. So H over M, H is joule and M is kg, so per kg. So this should have been the correct option. This one is for specific heat capacity, all right? So it's wrong. Pressure is force over area. So this should have been Newton per meter squared. So it's also wrong. So the correct option is B.